Assalamualaikum and a very good morning everyone. My name is Nur Shamimi Anis binti Azman Shibi, and this presentation I will be sharing my research titled LUFFA-based materials for the removal of dyes and heavy metals from wastewater. And this project is supervised by Dr. Nolaili Ahmad. So this presentation will cover the following key areas: research background, introduction, literature review, results, recommendation, conclusion, and references. Next, loofah is a natural biodegradable material from the cucumber family, well known for its fibrous and sponge-like structure. It's sustainable, non-toxic, and rich in functional groups like hydroxyl carboxyl, which make it a promising eco-friendly adsorbent. Its high porosity and large surface area allow it to absorb pollutants efficiently. Because of this characteristic, loofah has gained increasing attention for removing dyes and heavy metals from water. Loofah-based material, although conventional methods such as activated carbon, ion exchange, membrane filtration, and electrochemical treatments are effective, they come with limitations such as high operational costs, excessive chemical usage, poor regeneration, and sludge generation. This can result in ecosystem disruption and health hazards due to chemical residue and improper sludge disposal. Loofah-based adsorbent, in contrast, offer a low-cost, renewable, and environmentally harmless solution for pollutants removal. Problem statement. Industrial wastewater often contains toxic dyes and heavy metals which are non-biodegradable and harmful to both the environment and human health. Conventional methods are not always sustainable due to high costs and secondary pollution. Therefore, this study explores loofah-based materials, particularly modified forms, which can enhance absorption capacity, selectivity, and stability. So there are three objectives in the study. Firstly, to analyze the key properties of loofah-based materials for dye and heavy metals absorption. Next, to assess modification techniques that improve their performance. And lastly, to compare effectiveness and selectivity across multiple process variables. So from this objective, the guiding question are: what are the properties of loofah-based materials that contribute to their suitability for the absorption of dye and heavy metals from wastewater? Next, what are the methods used to modify loofah-based materials for absorption of dyes and heavy metals from wastewater? And lastly, how effective and selective are loofah-based materials for the absorption of dye and heavy metals from wastewater? So next, I will be moved to significance of study. So this study aims to support Sustainable Development Goals (SDG) by proposing a natural low-impact material to treat industrial wastewater. It provides insight for future research and practical application in water treatment technologies while reducing pollutant discharge and environmental risks. So this review supports a few SDGs such as SDG 6, which clean water and sanitation, SDG 15, life on land, SDG 14, life below water, SDG 9, industry, innovation and infrastructure, and lastly SDG 12, responsible consumption and production. Next, I will explain the two main properties of modified loofah materials. First is high surface area and porosity. Loofah has sponge-like structure with many small fiber, around 200 to 500 microcells. So this helps to have more contact with pollutants and absorb more dye and heavy metals. Second is the presence of functional groups. It has chemical groups like OH, COO, and CO found in cellulose and lignin. So this group help trap pollutants through hydrogen bonding and electrostatic forces. So both structure and chemical groups make loofah effective in removing pollutants. So next, there is some modification methods of loofah-based material to improve loofah performance. Firstly, base treated now remove lignin and increases porosity. Next, acid treated enhance surface area and active sites. Third, chitosan cross-linking introduce amine group for better binding. And lastly, thermal carbonization turns loofah into biochar, boosting surface area and adsorption rate. So this is the results. Table 1 and Table 2 show maximum absorption capacity for modified loofah under different conditions. So for heavy metals, chromium up to 70 milligram per gram with chitosan loofah, cadmium 16 milligram 60 milligram per gram using thermally carbonized loofah. Mercury and lead also show high absorption with acid treated loofah, and for dyes, methylene blue 150 milligram per gram, crystal violet 130 milligram per gram. Congorate and alurarate also had promising results depending on pH and modification type. So these results demonstrate the different modification methods impact selectivity and efficiency. For the recommendation for future study, there is limited information on the stability of modified loofah-based material. Therefore, future review on how to improve stability can ensure the firmly attached of heavy metals or dyes. The regeneration potential and long-term reusability of loofah-based material can also explore in future studies to assess their practicality for industrial scale applications. To conclude, this study confirms the high potential of loofah-based materials as green, sustainable, and low-cost adsorbents for removing dyes and heavy metals from industrial wastewater. Key properties of chitosan-based materials, modification like micro-sponge structure, high surface areas, and biodegradability makes loofah a promising alternative to conventional adsorbent. Performance is significantly improved through chemical cross-linking magnetic biochar derived from loofah with chitosan and treating sodium hydroxide (NaO) and physical modifications. And lastly, the comparative analysis across various modification methods and absorption conditions demonstrate that loofah-based materials can be optimized for improved effectiveness and selectivity of the loofah materials. So here are some references used to support this review. Full citation is provided in the written report. That's all from me. Thank you.